All right, this video is going to cover identifying radicals and whether they are rational or irrational. Going to be a pretty short video on this one. Just a quick refresher, what does it mean for a number to be rational? Okay, if a number is rational, that means it can be written as a fraction of integers. And it can be expressed as a decimal, as either a terminating decimal, a decimal that ends, or a repeating decimal. And then an irrational number, all the numbers that don't fit that qualification, it can't be written as a fraction of two integers in any way, shape, or form. And when we look at it as a decimal, its decimal representation will not end and it will not repeat. It will just, the digits will just continue on and on in no particular pattern. So it can be helpful for us to be able to recognize whether a radical is rational or irrational on sight. And we're going to use these two principles to determine that. First thing we have, any radical of a whole number that simplifies into a whole number is a rational number. That's pretty straightforward. But it leads to the more important thing, and that's that anytime we take a radical of a whole number that doesn't simplify to a whole number, it's going to be irrational. And so we can easily recognize radicals immediately, whether they're rational or irrational, if we know our perfect squares. Okay, so let's start this. We're going to identify each of these as rational or irrational. First, the square root of 36. Now, the question is, does that come out to be a whole number when we take the square root of 36? Is there a number that when we multiply it times itself gives us 36? And the answer to that is yes. It's 6. 6 times 6 is 36. Therefore, this square root comes out as a whole number, and this one is going to be rational. Next one, square root of 47. Is there a number that when we multiply it times itself gives us 47? The answer to that is no. It's really close to 7. 7 times 7 is 49. And we saw from part A, 6 times 6 is 36. So this is going to be somewhere between 6 and 7, but it's not going to come out to be a whole number, and therefore this one is irrational. Part C, square root of 15. Is there a number that when we multiply it times itself gives us 15? The answer to that question is no, and so this is going to be irrational. And then the square root of 81. Is there a number that when we multiply it times itself gives us 81? The answer to that question is yes. 9 times 9 is 81. And so this one is going to be rational. And that concludes our quick, easy video on how we can identify radicals as rational or irrational.